Today we'll be learning how to factor by greatest common factor. Oops. So in the multiplication problem 2x times x plus 4, we end up with 2x squared plus 8x. So we would say that 2x and x plus 4 are factors, and 2x squared plus 8x is the product. So the factors are what are being multiplied together, and the product is your answer. So to reverse that, 2x squared plus 8x equals 2x times x plus 4, we would say we have factored the product, which is 2x squared plus 8x, into the factors of 2x and x plus 4. So in the previous objective, we learned how to multiply, and now we are reversing that. We are going to factor polynomials. Okay, so let's just make sure we understand what are factors and what is the product. So in number 1, we have 3x times x plus 9 equals 3x squared plus 27x. The factors are what's being multiplied together, which is 3x and x plus 9. The product is 3x squared plus 27x. In number 2, the factors, what's being multiplied together, are negative 10x squared and x minus 6. The product is negative 10x cubed plus 60x squared. In number 3, the factors that are being multiplied together are 4xy squared and 3x plus 8y. The product is 12x squared y squared plus 32xy cubed. So the first step in factoring polynomials is to factor out the greatest common factor. So we spent some time last week going over greatest common factor. This is the largest integer and highest degree of each variable. So remember, degree is referring to the exponents. So the GCF of a polynomial is the largest integer and highest degree of each variable that will divide evenly into each term of the polynomial. So to find the greatest common factor of a polynomial, you're going to find the GCF of the coefficients. Oops. Remember, the coefficients are the big numbers in front of the variables of all the terms, and then find the largest number that goes, or not and then, but finding the GCF is finding the largest number that goes into all of them. Then you're going to find the GCF of the variables. So that is going to be the highest exponent. I'm sorry, that is not true. Let me redo that. The greatest common factor of the variables of all the terms, you're going to actually use the smallest exponent. So when we talk up here, where I highlighted in yellow, the highest degree of each variable, that will divide evenly into each term. which is going to end up being the smallest exponent that's in each of the terms. This will make more sense as we go on. Rewrite your answer as a single term, which is a product of the greatest common factors of the coefficients and variables. Okay. So, number 4, we need to find the greatest common factor for x, y squared and x to the power of 5, y to the power of 4. We don't have any coefficients in this one, so we're just finding the greatest common factor for the variables. For x, we have on the left side, let's see, x times y, if we expand these out. And then the monomial on the right, we have x multiplied 5 times and y multiplied 4 times. So we need to figure out what they have in common. They have in common 1x and 2 y's. So the greatest common factor is going to be x, y squared. In other terms, we would have x times y times y. So without expanding these, let's find the greatest common factor. So we need to find the greatest common factor for 8 and 18. For the coefficients, you're going to have to do the factor tree or the factor list, whichever way you prefer. I will make a factor list. So we can multiply 1 and 8, 2 and 4, and 3 is not a factor, so we're done there. For 18, we can multiply 1 and 18, 2 and 9, 3 and 6, 4 is not a factor, 5 is not a factor, so we're done there. So the greatest common factor for the coefficients is 2. Now, going by what we wrote up here, for the variables, we're just going to use the smallest exponent that they both share. So for x, we have a 5 and we have a 2. So we would pick x squared because it's the lower exponent with that variable. For y, we have 4 and 5, so we're going to use y to the power of 4. So the greatest common factor for these two terms is 2, and let me use the color here, 2 x squared y to the power of 4. Okay, number 5, 18x and 27y squared. So let's do the factor tree for this one, since we did the list last time. So I'm going to do 2 and 9, 2 is prime, and then 3 times 3, and then these are both prime numbers. For 27, we can do 3 times 9, 3 is prime, and then 3 times 3. So for 18, we have 2 times 2, 3, and 3. And for 27, we have 3, 3, and 3. So they have in common 2 3's. 3 times 3 is 9. So 9 is the greatest common factor of the coefficients. Now you'll notice that 18 has an x and 27 has y squared. They do not have any variables in common. So there is not going to be a variable in the greatest common factor. So the greatest common factor is just 9. Now that we know how to find the greatest common factor, we need to learn how to find that and then factor the polynomials. So we're going to be putting together what we just learned and what we learned yesterday, dividing by monomials. To factor polynomials, find the greatest common factor of the coefficients and factor it out. Divide each term by the GCF. Then find the GCF of the variables by finding the lowest exponent of each variable that will divide all terms and factor it out. Divide each term by the GCF. Move the GCF to the outside and write it in parentheses. Write in parentheses what is remaining after you factor out the GCF. So let's write out some steps here. You're going to write the GCF in front of parentheses. Then you're going to divide each term of the polynomial by the GCF. Then rewrite the remaining terms inside the parentheses. Okay, so we need to find the greatest common factor for 7x and 14y. So they do not have a variable in common. So there's not going to be any variables in our GCF, just a number. So I can look at this and know that the greatest common factor between 7 and 14 is 7. So I am going to divide each term by 7, and then I'm going to write 7 in front of parentheses. Now I just divide. So 7 divided by 7 is 1, and then I can just bring x down. So 7 cancels out. I end up with 1x or just x. 14 divided by 7 is positive 2, and y divided by, there's no y down there, so we just bring it down. So my factored form is 7 times x plus 2y. You can think of this as reverse distributing. So if we were to look at this problem, we would distribute the 7. We would multiply 7 times x and 7 times 2y, and you would end up with your original problem, 7x plus 14y. Okay, number 2. We need to find the greatest common factor for 18 and 12. The greatest common factor for 18 and 12 is 6. So this is why it's important for you to get fast at recognizing what the GCF is right away, so it doesn't slow you down in your process. And then I'm going to look at, they both have x. Which one has the lower exponent? That would be x to the power of 3. So that's what's going to be in my greatest common factor. So I'm going to divide both of these terms by the GCF, and then I'm going to write the GCF outside of parentheses and divide. 18 divided by 6 is 3, and then we have x. Subtract the exponent. 6 minus 3 is 3. Negative 12 divided by 6 is negative 2. And then we have 3 minus 3 for the x, so that cancels out. So my factored form is 6x cubed times 3x cubed minus 2. And then you can always check your work. If you were to distribute the 6x cubed, would you end up with your original problem? Okay, now we have a trinomial here, so we need to find what all 3 of them have in common. So we need a GCF for 17, 34, and 17. So I know that 17 times 2 is 34. So my greatest common factor is going to be 17 for the coefficients. The lowest exponent for A is 1, because this one has an invisible 1, and this one has an invisible 1. So it's just going to be a, and the lowest exponent for b is also 1. So my greatest common factor is 17ab. I'll keep that up here actually. So I'm going to divide each term by 17ab. Write it below, outside of the parentheses, and now we're going to divide. 17 divided by 17 is 1. It cancels out. A squared divided by a, remember we're subtracting the exponents, and if it's not there, then you know it's an invisible 1. 2 minus 1 is 1, so we just have a. And then for b, we have 4 minus 1, which is b to the power of 3, or b cubed. 34 divided by 17 is positive 2. A divided by a is 1, so we're just going to cancel that out. And then b squared divided by b to the power of 1 is b. 17 divided by 17 is 1. A divided by a is 1. B divided by b is 1. So we're just going to write plus 1. Now check your work. If you were to distribute 17ab, would you end up with this original answer? And we would. Okay, now this one, it looks a little bit different because we have two terms here, but within the terms, they are in factored form. So they each have two factors. So we have 3x times x plus 1 minus 4 times x plus 1. What they have in common is x plus 1. Because they're in parentheses, they are considered a factor. So the greatest common factor is x plus 1. So what we'll do is keep it inside of parentheses. So let's divide by the GCF, x plus 1. And then I'm going to write it here in front of another set of parentheses. And what's left over is going to go in the second set, 3x minus 4. Okay, so let's look at some polynomials where the leading term, the leading coefficient, is negative. So if the leading coefficient is negative, you must always factor out the negative. So you're always going to make your greatest common factor negative if the first term in the polynomial is negative. So we can see that negative 5 is the first term. We're going to write negative here. We know it's going to be negative. What's the greatest common factor for 5 and 35? That would be 5. The lowest exponent for x is 1, and the lowest exponent for y is y, or 1, sorry. So our GCF is negative 5xy. Divide each term by the GCF. Write it outside the parentheses, and then divide. Negative 5 divided by negative 5 is 1. X squared divided by x is going to be x. Y divided by y is 1, so it cancels out. Now we have 35 divided by negative 5. That's negative 7. And then x divided by x is 1. Y divided by y is 1. So your answer is negative 5xy times x minus 7. Number 10, it's a trinomial, so we need to find the greatest common factor of all three. The leading term is negative, so I'm going to put negative in my GCF. The greatest common factor for 2, 14, and 6 is 2. The lowest exponent for x is 1, so our GCF is negative 2x. And now we divide. Negative 2 divided by negative 2 is 1. X to the power of 4 divided by x is x cubed. 14 divided by negative 2 is negative 7. X squared divided by x is x. Negative 6 divided by negative 2 is positive 3. And x divided by x is 1. So today you'll be finding the greatest common factor and factoring polynomials.